welcome to the deep dive. If you're listening, you probably want to get a quick, solid understanding of how mobile devices talk to all those services out there. Without getting totally bogged down in technical jargon.
Yeah.
So think of this as your clear path to understanding mobile connectivity.
Exactly. We've got some great material to work from today, and yeah, our mission is to really break down SO and REST.
Right.
Those are two really key ways apps communicate, and also how they handle data using XML and JSON. We'll try to make it all pretty clear and practical.
Okay, perfect. Let's dive straight in then. SOAP, Simple Object Access Protocol. The materials describe it as a way for different applications to talk, even if they're built completely differently.
That's spot on.
Different OS, different languages, the whole 9 yards.
Yeah, that's the real power of S. It creates interoperability. So,
Right.
Think about an app on your phone, maybe an Android weather app. It needs data from, say, a government server running a totally different system. SAP is like that translator, that common language, allowing them to exchange information smoothly.
And it has these 3 main characteristics, right? Extensibility, .neutrality, .independence.
Precisely. Those are its design pillars, you could say. Extensible means you can add features. Neutrality is key. It's not locked into just web protocols like HTTP. It can run over email, SMTP, or even TCP, UDP, more direct connections. And independence means it doesn't dictate the programming model used by the apps.
So it's flexible.
Very. And it's important to see SOP not just as one thing. It's a communication protocol, sure, but it's also an object access protocol, and it defines the actual format for the messages. It's sort of a complete package.
Okay, so the message format, that's XML, right? When an app sends a SOP message, it's sending this structured XML document.
Exactly. It's not just raw data.
Can you give us a quick look inside? What are the main parts?
Sure. So every SOP message, it's wrapped in what's called an envelope. That's the outermost layer, clearly marking it as SOAP.
Okay.
Inside that, you can have a header. It's optional, but it carries important stuff.
Yeah.
Maybe security tokens or transaction IDs.
Right.
Then comes the body. That's the core. It holds the actual call information, the request, and then later, the response data.
The actual payload?
Pretty much.
Yeah.
And finally, there's a fault element. If anything goes wrong, errors or status info goes in there. It's like a standard business letter format almost. Envelope, header, body, and a section for problems.
That structure makes a lot of sense. Everything's got its place. Now, what about WSDL? That often comes up with SAP.
WSDL, Web Services Description Language.
Yeah.
Yeah, it's absolutely vital in the SOAP ecosystem. Think of it like the instruction manual or the contract for a SOAP service.
Okay.
It's an XML file itself, and it spells out exactly what operations the service offers, the structure of the messages it expects, the data types involved, everything.
So it tells developers how to use the service.
Precisely. Before you connect, you look at the WSDL to know how to talk to that service. What can I ask it? What will I get back? It's machine-readable documentation, essentially.
Got it. So for an Android developer needing to connect to one of these SOAP services, the material mentions the KSOAP2 library.
Right. KSOAP2 is a very common choice for Android. It simplifies dealing with all that XML structure and the network communication.
How does it work, roughly?
Well, it has a few key classes. There's SOAP object. You use that to build your request, basically setting the method you want to call and adding any parameters it needs.
Okay.
Then there's SOAP serialization envelope. That takes your SOAP object and wraps it up in the correct SOAP XML envelope structure. It serializes.
Wow, the enveloping part.
Exactly. And finally, HTTP transport C is the class that actually makes the connection over HTTP and sends that SOAP message off to the web service.
And there's specific methods developers use a lot within KSOAP2.
I'll tell you, when you're setting up that SOAP object request, you'll use add property repeatedly to add each parameter. When you're setting up to receive the response, set output SOAP object tells the library which object should hold the incoming data.
Right.
And the main one is call. That's the trigger. It executes the network request, sends the message, and waits for the reply. Pressing send, basically.
Okay, that gives us a pretty good handle on SOP. Let's switch gears now. REST services. The material really emphasizes that REST just uses HTTP, the standard web protocol.
Precisely. REST, representational state transfer, it's a different philosophy than SOAP. Instead of defining a whole new protocol stack, it leverages the existing infrastructure of the web, HTTP.
Which makes it
generally simpler, lighter weight, often easier to get started with, especially for web and mobile apps where HTTP is already the foundation. It's like speaking the native language of the web.
And with REST, specific HTTP actions are crucial. get, post, put, delete.
Yes, those are the verbs of REST. Get is for retrieving data, like getting your emails.
Yeah.
Post creates new data, posting a status update. Put updates existing data, editing your profile. And delete, well, that's obvious. It removes data.
Very intuitive mapping to data operations.
Extremely.
And when a REST service sends back data, what format does that usually take?
The two big ones are JSON, JavaScript Object Notation, and XML, which we already talked about with SOAP.
Right.
JSON has really taken off, especially for APIs feeding web and mobile apps. It's lightweight, text-based, and super easy for JavaScript, which powers a lot of the web to understand.
That makes sense.
Yeah.
Which leads us nicely into processing these formats.
Yeah.
Let's tackle XML first. The materials say XML represents things as nodes.
That's the core idea, yeah. Think of an XML file like a tree structure. Every piece of data, an element like book, an attribute like isbn123, even the text inside an element is a node.
A tree, right?
There's always one main root node and everything else branches off. Elements can contain other elements or text or attributes, and attributes are like child nodes attached to their element.
And its main job is storing data and its structure in a way that's readable for both people and machines.
Exactly that. It standardizes how data is described and organized so different systems can exchange it without needing to know the internal details of the other system. The simple root element example shows that basic nesting.
Yeah, and the more detailed library example with book elements inside author, title, publisher that really shows how you build up complex, structured information.
Right, and notice how things can be nested, like the author's name inside the author tag. That lets you create really rich data hierarchies. And if a book had multiple authors, you might just see multiple name tags inside that one author element in XML.
Okay, so how do applications actually read this XML? The material mentions a few libraries, SAX.
SAX, yeah. Simple API for XML. It's an event-based parser. It reads the XML document sequentially from start to finish.
Sequentially.
And as it reads, it triggers events like start of element found, end of element found, text found. Your application provides a handler that listens for these events and reacts accordingly.
So it doesn't load the whole file at once.
Correct. That's its big advantage. It's very memory efficient, great for huge XML files because it just processes piece by piece.
Then there's XML pull. Also sequential.
Also sequential, yes. XML pull from org.xmlpull.v1 is similar in that it reads step by step, but instead of the parser pushing events to your handler like SAX does, with XML pull, your code actively pulls the next event from the parser. You ask what's next, and then process it. Gives you a bit more direct control over the iteration.
Okay, pull versus push. And the third one, DOM document object model. That sounds different. It loads the whole structure.
Totally different approach. DOM reads the entire XML file and builds an in-memory tree representation of it. Like, the whole structure lives in your RAM. You use a document builder factory, then a document builder, and its parse method gives you back a document object, which is the root of that tree.
What's the advantage of that?
It makes it really easy to navigate around the structure. You can jump between nodes, modify things easily, but the downside is memory. For very large XML files, loading everything into RAM can be a problem.
Right. And within DOM, there are key bits like node, element, nodalist.
Yeah. Node is the basic interface for anything in the tree, an element, an attribute, text. Element is specifically for, well, XML elements like book. And nodalist is just a collection of node objects. It has an item method to grab a specific node from the list.
And useful methods like get elements by tag name on the document.
Exactly. That's super useful. You call get elements by tag name, book, on your document object, and you get back a nodal list of all the book elements.
Nice.
Then on an element object, you can use get attribute is bn to get an attribute's value, and get text content gets the text inside an element.
The material mentions a real-world example, parsing exchange rates from the National Bank of Romania J01 XML parsing.
Yeah, that's a classic use case. Lots of public data is still published in XML, so knowing how to parse it is essential for pulling out the specific bits you need.
Definitely. Okay, let's move over to JSON processing. Originating from JavaScript, often seen as simpler than XML.
That's the general consensus, yeah. JSON was specifically designed for lightweight data interchange. It uses the JSON extension. Its strength is representing simple structures. Text, numbers, booleans, and collections of those.
And the syntax is pretty straightforward. Curly braces for objects, square brackets for lists or arrays.
Exactly. And inside objects, you have key value pairs like property, Value. Keys are always strings in double quotes, then a colon, then the value.
The value can be a string, number, true, false.
Or another object or an array. So you can nest structures just like in XML, but the notation is often considered cleaner, especially for web developers.
We saw the library example again, but in JSON. The difference with the multiple authors was interesting. It was an array inside the author field.
Right. That's a common pattern in JSON. Instead of repeating tags like XML might, JSON often uses an array to hold a list of values, like multiple author names or objects, can be more compact.
Okay. Now, for using JSON and Android, retrofit comes up. Sounds like a big deal.
Oh, retrofit is huge in modern Android development. It's a library that dramatically simplifies making network requests, especially to RESTful APIs that return JSON.
How does it work? What are the main parts?
It revolves around a few concepts. You create POJOs, plain old Java objects. These are simple Java classes that exactly match the structure of your JSON data.
Like a model class.
Exactly, the data model. Then you define a Java interface. This interface maps out your API, calls the URLs, the HTTP methods like get, or post.
Okay.
And finally, there's the REST adapter class, which is like the engine. It handles setting up the connection, making the call, and converting the response.
It usually uses another library, JSON, to do that JSON to Java object conversion automatically.
By default, yes. Grayson is incredibly good at taking JSON text and turning it into instances of your POJO classes and vice versa. Retrofit is built to work seamlessly with Grayson, but it's pluggable. You can use other converters like Jackson if you need to.
Those helper websites mentioned, JSON schema2pujo.org and the like, for generating POJOs from JSON. That sounds really handy.
Absolutely massive time savers. You paste in some sample JSON and boom, it spits out the Java class definition. Saves you from writing all that repetitive getter-setter code and helps avoid typos when matching the JSON structure.
Let's look closer at that retrofit interface. It uses annotations, right, like at get.
Yes, annotations are key. You define a method in your interface, say get weather. Above it, you put at get data 2.5 weather. That tells retrofit. This method makes an HTTP GET request to that specific path relative to the base URL.
And you can add parameters.
Yeah, using annotations like @queryQ, string city, or @queryAppid, string APIKey. Retrofit automatically adds those as query parameters to the URL.
And the response handling.
Typically, the method signature includes a callback your POJO class. When the network call finishes, Retrofit uses JSON to convert the JSON response into your POJO class and delivers it to your callback object.
And the REST adapter ties it all together, setting the base API URL.
Correct. You use a REST adapter builder to specify the main endpoint for the API, like https://api.openweathermap.org. Then you call .build to get the adapter, and finally .create your service interface.class to get a working instance of your interface.
Got it. Now, besides retrofit JSON, the material also mentions the basic org.json library. When would you use that directly?
Maybe if you're not using retrofit, or if you need really low-level manual control over parsing, or perhaps if the JSON structure is very simple or dynamic and doesn't easily map to a fixed POJO.
Big offer.
It gives you JSON object to represent a JSON object with methods like getString_key, getIntKey, getBooleanKey to pull out values.
Yeah.
And methods like getJSONObjectNestedObject or getJSONArrayList to navigate deeper. Then there's JSONArray for lists with length and getIndex methods to access elements. It's more hands-on parsing.
And there's a JSON array for example reference for that too.
Exactly, showing how to use those JSON object and JSON array classes directly.
Okay, nearly there. Finally, the materials briefly list some other important support libraries. OKHTTP, Volley, ArcsJava, Grayson again, Jackson.
Yeah, just a quick rundown. OKHTTP is a very efficient underlying HTTP client. In fact, Retrofit uses it internally.
Okay.
Volley is another networking library from Google, offers image loading and request queuing features. ArcsJava helps manage asynchronous stuff like network calls in a more reactive, streamlined way.
Right.
We've talked about Grayson for JSON. Jackson is another very popular and powerful library, similar to Grayson, but also handles other formats like XML, CSV, etc. Lots of tools in the toolbox.
So wrapping this up, it's clear that connecting mobile apps to services involve these main pathways, res, array, and rest, often dealing with either XML or JSON data.
That's the big picture, absolutely. SOAP, robust, protocol agnostic, often XML-based, uses WSDL. REST lighter, leverages HTTP, often uses JSON, relies on standard HTTP methods.
And we've seen the tools for handling that data in Android, KSOP2 for SOAP, SAX, POL, DOM for XML, and org.json, often with retrofit, for JSON.
Exactly. Which really leads to a final thought, something for our listeners to chew on.
Okay.
Given the differences we've discussed, the strengths, the complexities of SOAPy versus REST and XML versus JSON, in what kinds of mobile apps or specific situations might one approach be clearly significantly better than the other? Think about things like enterprise system integration versus a simple social media feed, or the need for strict contracts versus flexibility. Performance needs. It's not always a simple choice, is it? Lots to consider in that landscape.